lecture, we will be studying about a regular grammar. So before we start a regular grammar, let's try to understand what is a grammar. So in human languages, what is used a grammar or why do we use in a grammar? So a regular grammar is a formal structure used to generate strings in a language by following specific rules and symbols. It is a mathematical object with 4 types of grammar. So Noam Chomsky gave a mathematical model of grammar, which is effective for writing computer languages. The 4 types of grammar according to Noam Chomsky are Type 0 of grammar, Type 1 of grammar, Type 2 of grammar, and Type 3 of grammar. So we will discuss them start from the bottom. So Type 3 grammar. This grammar accepted our regular grammar. In the language accepted the regular language. And automaton are finite state automaton. And the type 2 grammar accepted context-free grammar. And language accepted context-free language. And automaton push-down automata. And the type 1 grammar accepted context-sensitive grammar. Language accepted are context-free language. And the automaton are linear-bounded automaton. The last is type 0. Grammar accepted unrestricted grammar. And the language accepted are recursively enumerable language. The last automaton are Turing machine. And so here we will see how can formally describe grammar. So a grammar G can be formally described it using 4 tuples as G equal to V, T, S, and P. V equal to set of variables or non-terminal symbols. T set of terminal symbols. S is start symbol. And P production rules for terminals and non-terminals. So they are example of grammar. V is equal to is A and B is a non-terminal symbols. T equals A, B. This is a terminal symbols. Is equal to is. And P is equal to is gives to AB. And A gives to A. And B is gives to small b. And so regular grammar. Regular grammar can be divided into 2 types, right linear grammar and left linear grammar. Right linear grammar, a grammar is said to be right linear if all productions are of the forms. A also gives xb, A also gives x, where AB belongs to V and x belongs to T. So for linear grammar, a grammar is said to be left linear if all productions are of the form. A also gives Bx, A also x, where AB belongs to V and x belongs to T.